Okay, this is the second type of cross-bearing fixed problem that you'll come across. I'm going to draw a couple of triangles here. So let's have a look at the problem. At 0800, the vessel Aquajet is on a bearing of 270 degrees true. Your navigator notes the bearing of the tower at 0 degrees true. At 8:30, the bearing of the same tower is at 45 degrees true, and we know that Aquajet is cruising at a speed of 18 knots. So the task is, 1, to sketch the information, to determine how far the vessel has moved from 8 to 8:30, and then work out how far the vessel is from the tower at 8 o'clock. We'll need to work out how far the vessel is from the tower at 8:30, and then at 9 o'clock, if it's going at the same speed and direction, what's the bearing of the vessel from the tower at 9 o'clock? So let's have a look at this. So I've drawn in a line here to designate that this is going left, or 270 degrees really, isn't it? So west is 270 degrees, so I've just drawn a line from left to right. Here's our vessel at 8 o'clock, and we know that the tower is 0 degrees true, which is just due north. So let's draw that line in. We now, just somewhere along that bottom line there, put a protractor. Make sure the protractor lines up with the line, and we're just going to work out a 45-degree angle and connect that one up with the line. So we just remember to get 45 degrees from here to here, and let's continue. Well, we know that the vessel is travelling at 18 nautical miles per hour. It's only gone for half an hour, so it's got to be at only half that 18 nautical miles, which is 9 nautical miles. Now this is good too, because we are now forming an isosceles triangle. If you notice here that this is 45 degrees and this is 90, so that means this has got to be 45 degrees. And we know that with isosceles triangles, the base angles are equal, therefore the sides must be equal. Therefore this side must be 9 nautical miles as well. So let's continue. We know that the vessel is travelling at 18 nautical miles per hour. We did 9 nautical miles in half an hour, so in another half an hour we've gone another 9 nautical miles, which is a total of 18 nautical miles. All we need to do now is connect that up to where we know the tower is, just here, and put our protractor on that line. Make sure 0 is pointing to true north, and measure the bearing of that line. So if I'm looking at question 4 now, how far is the vessel from the tower at 8:30? We can solve this a couple of different ways. We can do it through trigonometry or Pythagoras theorem, because we know that we know the angle there, and we know the opposite, and we also know the adjacent sides down here. So here's our opposite, here's our adjacent. So we're going to use cosine this time to work out the hypotenuse, and I think we're working out the hypotenuse of this one at 8:30. Yeah, that looks like it. So we know that with Sokotoa, SOHCAHSRTOA, so let's just use the cosine ratio, and that's CAH. So we know that the cosine of 45 degrees, here's our 45 degrees here, is got to be the adjacent over the hypotenuse. Here's our adjacent, 9 nautical miles, and here's our hypotenuse. So if we substitute, we know that cosine 45 degrees equals 9 divided by the hypotenuse. We need to rearrange that to say that the hypotenuse is the same as 9 divided by the cosine 45 degrees. We plug that into the calculators and we get 12.72 nautical miles. If we have a look at question 5, we can also work this out through trigonometry. And we know with trigonometry that opposite and adjacent form the tangent relationship. So we're just saying that tan theta, here's our theta here. Tan theta equals the opposite, which is 9 over 18. So tan 45 equals opposite over adjacent. Therefore, we need to rearrange that a little bit. Just say theta degrees equals tan to the negative 1, 9 over 18. We plug that into the calculator.